Welcome again, Wildcats. All right, so today we're looking at Wednesday, March 22nd, and we're looking at application of exponential functions on page 65. All right, and just a reminder, on Thursday, March 23rd, we're going to do test 9 retest. All right, so if you would, pause the video and update your table of contents. All right, now your table of contents are updated, let's take a look at our notes. All right, which are going to be on page 65, and we're looking at application of exponential functions. Now I've defined each variable in a different color, so if you want to pause the video for a moment and grab a green, yellow, orange, blue, and a red, or just if you want to do them in different colors, that's what I did. All right, I'm assuming at this point now you've paused it if you need to get colors. If not, let's go ahead and move on. All right, so X is time, Y is the final amount, A is the initial amount, R is the rate, converted to decimal. Rate is always in the decimal. And then N is the number of times compounded. All right, so now that we've defined the variables, let's look at each of the functions. So we have exponential growth, okay, which is y equals a, parentheses 1 plus r raised to the x power, okay? Now notice growth plus growth, okay? Exponential decay is y equals a, parentheses 1 minus r raised to the x power, okay? So notice decay minus growth plus. So if you would, pause the video and write down your exponential growth and exponential decay. All right. So let's look at compound interest and compounded continuously. Okay, so compound interest is y equals a, parentheses 1 plus r divided by n raised to the n times x power. And then compounded continuously is y equals ae raised to the r times x power. Okay, so pause the video and update your compound interest and compounded continuously. All right, now that those are updated, let's take a look at our examples. All right, so example 1. Okay, if you deposit $5,000 into a savings account, paying 1% annual interest, how much will be in the account after 30 years? Okay, so the key here are savings and interest. Okay, so that tells you that we're looking at growth. Okay, so it says annual interest. Okay, so annual means one time. Okay, one time. Okay, so we're looking at the compound interest formula. So that's y equals a is the initial amount, which is 5,000, parentheses 1 plus, now the rate's 1%. 1% converted to a decimal is equal to 0.01. Okay, so that's 1 plus 0.01 divided by, now annual is 1, so divided by 1 raised to the 1 times 30. Okay, so to put this in a calculator is pretty straightforward. Okay, so you do 5,000 parentheses 1 plus 0.01 divided by 1. Now, if you want to get fancy, you can actually press Control Divide, and you can put 0.01 divided by 1. Click to the right twice. Now, there's a key underneath the equal sign. Looks like a triangle. Press that. Raise to 1 times 30, which equals $6,739.24. Okay, so let's write that down. So that's $6,739.24. Now, whenever you're solving a word problem, you always write your conclusion as a sentence. So in this case, it says, how much will be in the account after 30 years? So you would say the account will have $6,739.24 after 30 years. All right, now I did this problem on purpose because I wanted you to see that savings accounts are basically worthless, okay? For if you're trying to make money, okay? This was after 30 years, you only had $1,739 more after that in investment. So, and that's what basically savings accounts have is 1%. Okay, so savings accounts you only want for like emergencies. So basically, if you lose your job or if you have like your roof gets destroyed or you have like a medical emergency, you have that just so you have basically money. Okay, what you need to look at is individual retirement accounts. Okay, they average anywhere from 8% to 15% interest. Okay, and I challenge you to redo example one with 0.08 or 0.15 and see the difference of how much money just on one initial $5,000 investment. Okay, so go ahead and you can just get a separate sheet of paper out. But go ahead and take a separate sheet of paper out and then do example one with 8% and with 15%, and just write that down and calculate that. See the difference. All right, so pause and do that. All right, so you did that. So now ask yourself, which account do you need to really put money in? A savings account or an individual retirement account? Okay. And then write that down and tell yourself, because the moment you graduate, you need to be thinking about which account to put your money in to basically invest and make money. Okay. All right. Example two. Mr. Flowers purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. How much will it be worth in 5 years? So let's just answer that question first. How much will it be worth in 5 years? Okay. So it says purchased a rare guitar, experts increase. So the key there is increase. So we know increase is growth. Okay. So we go to our growth equation. So that's, we don't know the final amount. That's what we're looking for. So that's y equals, we know the initial amount of the guitar is $12,000. Okay. Parentheses 1 plus the rate, which is 14% converted to decimal, is 0.14 raised to the 5 years. Okay. So at this point, I've already showed you how to put one of these in the calculator. You can either just use your Desmos, so you can use the Inspire. If you're in class, you can use the Inspire. If you're at home, you can use Desmos, but you can plug this into the calculator. So I'm just going to do that. So 12,000 parentheses 1 plus 0.14 raised to the 5 years is $23,105. All right, so again, as always, when you answer a word problem, you're going to write your conclusion in a sentence. So it says, how much will it be worth in 5 years? So you would say, the guitar will be worth $23,105 after 5 years. All right, now the next question says, when will the guitar be worth $60,000? Now, the $60,000 is the final amount, okay? So instead of y, we know the final amount, which is $60,000. Now you might just put a comma just to make sure that you have the right zeros. I always have trouble when I'm writing out so many zeros. but the comma helps you catch that you have the right zero. So 60,000 equals, now we know the initial amount, which is 12,000. Okay, I'm going to slide the first part of this out of the way. So 12,000, okay, parentheses, 1 plus is still at 14%, so 0.14. But in this case, we don't know the number of years, which is x. Okay, so at this point, we haven't gone over how to solve this algebraically. So what we're going to have to do is solve it graphically. Okay, so to solve it graphically, we divide. Let's go ahead and divide the 12,000 by both sides. Okay, to just reduce the numbers a little bit. So if you divide 60,000 by 12,000, we get 5. And 12,000 divided by 12,000 is 1. So 1 times, and we can go ahead and calculate 1 plus 0.14 is 1.14, and that's raised to the x power. Okay, at this point, we're going to solve by graphing. So we're going to graph the left side and the right side. Now, mathematically, technically, you could have used the 60,000 and 12,000, but by dividing the 12,000 by both sides, we've made the number smaller, so it's going to be easier to see on the graph. Okay, so pause a minute to write that down. All right, now that you have that written down, okay, I'm going to zoom in on the screen so you can see the screen. Okay, so I'm going to go to On, New Document, No, Add Graph. All right, so I'm going to graph the left side first. I'm going to graph 5. Okay, and then I'm going to press Tab, and I'm going to graph. Now, but I almost forgot. If at this point you're like, man, I'm at home and I'm watching this video and I don't have a calculator. Well, remember, I'm not here on Wednesday, so you could be doing this in class. Okay, so 1 parentheses 1.14 raised to the x power. Okay. Now, it looks as if they intersect here, but we're not sure. So we're going to go to Menu, Window Zoom, Zoom Out. I'm just going to click once. Okay. And then you still have the zoom feature, so I need to press the escape key to get out of zooming. Now that we see it's intersected, okay, I'm going to go to Menu, View, Grid, Line Grid. And you can see that it looks like it crosses an exact point, but I'm not sure, okay? So when you're not sure if it crosses an exact point, we can do this. I didn't show you this in class on Tuesday, but I'm going to show you now. You can go to Menu, Analyze Graph, and you can actually pick Intersection, okay? Now you're going to move the cursor all the way to the left, and then you're going to click, and you're going to drag until you see the word intersection. You see the word intersection at the right here, and it gives you the point. Now, it's hard to read, so you see the hand. I'm going to move the hand over that point, and I'm going to press Control-click. And I'm actually going to drag it so I can see it, and then click away. And I can see that the intersection is at 12.3, 5. Now, when you're looking at the intersection point, you're only looking at the x value, okay? So we know now that the guitar will be worth 60,000 in 12.3 years. Okay, so x equals 12.3. So remember, you always write your conclusion in a sentence. So you write, the guitar will be worth Sorry, I accidentally knocked the camera out, so I had to readjust that. The guitar will be worth $60,000 in 12.3 years. All right, so pause a minute to finish up example 2. All right, let's look at example 3. Okay. Now, example 3 says the value of a Chevrolet Corvette bought new for $55,450 decreases at 9.5% each year. When will the value be $5,000? Now, I initially had that because if you go to Chevrolet and you look up how much a Corvette is, that's what your base price of its Corvette is going to be. But then the frugality means like, man, why are you going to buy a brand new car? That doesn't make any sense. So I did some research and I realized that you can get a used Corvette for $28,000. Okay, so we're going to change our value. So the price of the Corvette, let's go to $28,000. Okay, let's get a used Corvette. It saves us a lot of money. Okay, so the key words in here is decrease. Okay, so that tells us exponential decay. Now, we don't know the final value. That's what we're looking for. Oh, actually, no. I'm sorry, we do. It's asking us when will the value be 5,000. So we know the final value. So 5,000 equals the initial value of the car is 28,000. Okay, parentheses 1 minus the rate is 9.5%, which as a decimal is 0.095. And we don't know at what year the car will be worth 5,000. Okay, so again, at this point, we don't know how I haven't taught you how to algebraically solve it, so we can solve it by graphing. But before we do it, let's divide both sides by 28,000. That will reduce the numbers to graph. So if you divide both sides by 28,000, you'll get 5 divided by 28 equals 20,000 divided by 28,000 is 1. So 1 times, and when you subtract 1 minus 0.095, it is 0.905. And then that's raised to the x power. Whoa, what was that? My hand was frozen in time. Craziness. All right. So at this point, we're going to solve by graphing. Okay, so pause a minute to write down example 3. All right, now you have example 3 down. Let's go ahead and solve this by graphing. All right, so again, I'm going to go to on, new document, no, on, new document, no, add graph. All right, so we're going to graph the left side. So I'm going to press Control divide, 5 divided by 28, and then tab 1 parentheses 0.905 raised to the x power. All right, so it looks like they're going to intersect, but we can't see the intersection, so we're going to go to Menu, Window Zoom, Zoom Out, and I click. Maybe let's click again. All right, that looks like we have the intersection point. It's a little hard to see, but it looks like we have it. So we're going to press Escape, and then go to Menu, Analyze, Intersection. Move the cursor all the way to the left, just so we're testing every area. Click and drag. I'm going to stop when I see the word intersection. I get the word intersection, so I'm going to click. I can't see the point, so I'm going to control click with the hand, grab the point, and move it so I can see it. Okay. Now remember, whenever you're looking for the intersection, you're only looking for the x value. So x is going to be 17.3, okay? So x equals 17.3. Okay, but remember, whenever you're answering a word problem, you're going to write your conclusions in a sentence. So you'd write the value of the car. I'm going to say car. It's not car, Corvette. Sorry, Corvette. Didn't mean to call you a bad name. Don't never call Corvette a car. They're Corvettes. Corvette, the value of the Corvette will be $5,000 after 17.3 years. Wow, that's a lot of loss in value. So, last and only just life advice: never buy a new car, and never spend a lot of money on a car because the value will depreciate. Okay. All right, but go ahead and finish up example 3. All right, let's look at example 4. All right, if you invested $5,000 at 5% interest compounded, so that's important, compounded quarterly, how much will the investment be worth after 5 years? So let's answer that question first. Now, compounded quarterly is huge. That tells us that we're doing compound interest, okay? So let's see do we have the final amount. If you invested $5,000, so we know how much the initial, we don't know the final, so that's y equals the initial investment amount is $5,000 at a rate of 5%. So that's now 5% of decimals, 0.05. So that's 1 plus 0.05. Quarterly is 4. Think 4 quarters in a dollar. So 4 raised to the 4 times, in this case, 5 years. All right. And again, I already showed you in example 1 how to put that in the calculator. So let's just plug that in. So 5,000 parentheses 1 plus 0.05 divided by 4 raised to the 4 times 5. So that's $6,410.19. So again, as a word problem, you always write your word problem as conclusion. So in this case, you'd write the investment will be worth 6,700 that's about to be a mistake. $6,410.19 in 5 years. So look at example 1 and example 4. Just a 5%, and then we're doing compounded quarterly. Those two changes, you're making almost what you made in 30 years at 1% annually. Okay. So these are big numbers, big concepts you want to understand because you want to understand how to invest. Okay. All right. Let's look at now. The second part says, when will the investment be more than $100,000? Okay. So now the $100,000 is the final amount. Okay. So I'm gonna move this over. So 100,000, and I'm just putting a comma just so I make sure I have the right zeros. Okay, 100,000 equals, we still know our initial investment's 5,000 and we still know it's 1 plus 0.05 divided by 4 raised to 4 times 5. Okay, now again, we're going to solve this. Well, wait a second. Made a mistake. Can anybody catch what mistake I made? All right, I'm hoping that you caught, wait a second, it's not 5 because we don't know when the investment. So it's actually 4x. Okay, we don't know how long it will take to get to 100,000. Okay, so again, we're going to solve by graphing, but we're actually going to divide both sides by 5,000 to make the number smaller to make it graphing easier. So when you divide both sides by 5,000, so 100,000 divided by 5,000 is 20. So 20 equals 5,000 divided by 5,000 is 1. Parentheses 1 plus 0.05 divided by 4 is 1.0125 raised to the 4x. Okay, so go ahead and write that down, and then once you have it written down, we'll solve it by graphing. All right, so now let's solve it by graphing. All right, so on new document, no, add graph. So we're going to graph the left side, which is 20, and then tab 1 parentheses 1.0125 raised to the 4x. Now, we don't see the intersection, so we're going to go to Menu, Window Zoom, Zoom Out, and I'm going to zoom out until we see the intersection. We're almost there. Let's zoom out again. We have the intersection, so I'm going to press Escape, and then we're going to go to Menu, Analyze Graph, Intersection, remove the cursor all the way to the left, click, and then drag, and I'm going to stop when I see the word intersection. Got the word intersection, so I'm going to click. I'm going to move the cursor over the point, Control click, and move the point. And remember, when we find the intersection, we're only looking at the x value. So in this case, x is 60.3. All right, so x equals 60.3. Okay, now the question says, when will the investment be more than 100,000? So you again write your conclusion. The investment will be more than 100,000, comma, dollar symbol, after 60.3 years. Now, pause for a minute. Is that good? I want you to think about it. Is that good or bad? All right. So if you said good, I'm thinking that you said good because, well, you took a $5,000 investment and made it into $100,000. I think that's pretty good. But it's bad because it took you 60.3 years. So that means if you're 30 years old, then when you are 90, you could get the money. But now it's good. Now, if your parents are smart, you might talk to them and say, hey, Mom, Dad, can you go ahead and get me some money invested? Because if you're, say, I don't know, born, so when you're the year you're born, your parents say, you know what, I'm just going to put $5,000 and let it invest. When you're 60 years old, you have $100,000. And that's not even including if you put more money into that. So it's I don't know about y'all, but I think it's so cool how the interest percents and compounded can make a huge difference in the money you have. And I enjoy it when I look at my accounts. I'm like, wow, I just made $300 today based on a $14,000 investment. So it's kind of cool. And see that what's even cooler is that money you earn keeps getting invested, right? So you're making money on money. All right, so let's look at example 5. What is the total amount for an investment of $1,000 invested at 5% for 10 years compounded continuously? So the key word is continuously. Okay, so we know the format compounded continuously. So we know that we don't know the final amount, so that's y equals the a value, which is 1,000, parentheses, not parentheses, e raised to the rate 5%, which is 0.05, times the years, which is 10. Okay, so go ahead and pause a minute to write that down. All right, so let's go ahead and put that in the calculator. Okay, so go to New Documents, No, Add Calculator. So you put 1,000. Now the E key is right here, and so all you have to do is press that button right there. So E raised to the 0.05 times 10, which is $1,648.72. Okay, so $1,648.72. Okay, so again, you always want to conclude. It says, what will the total amount be? And you would just say the total amount would be $1,648.72. All right, so with that, go forth and finish the rest of your exponential functions assignment and have an exponentially awesome Wildcat day.